This is the first lesson in the series pack. First thing we're going to do is just look at some algebra skills which are necessary for answering these types of series questions. And then we're going to look at the actual series content. First off, we're just going to practice a bit of factorizing here. So in these series questions, you will get expressions such as this quarter k squared thing here. And what you absolutely do not want to do with these is to expand them all out into a quartic, and then try and use your calculator to solve it and factorize it that way. That's absolutely not what you want to do. What you need to do is factorize this as far as you can first before you start expanding things out and simplifying. You should never really be expanding more than a quadratic in these sorts of questions. So the first thing we're going to do here is look to factorize things out. So I want to factorize out k. These both have a term, k term equal. And I want to factorize out k plus 1 as well. I also want to look at the number term. So what I'm going to do is I'm going to write these over a common denominator so I can factorize this too. And a common denominator for these will be 12. So I'm going to write this quarter here as 3 over 12, and I'm going to write the 6th as 2 over 12. Then the first thing I can do is factorize out the 1 over 12. I can factorize out the k that they both have in common, and factorize out the k plus 1 that they both have in common. From the first term, this leaves behind the 3 over 12, the 3 on the top, leaves behind one of the other k's, and leaves behind another of the k plus 1s. From the second term, it leaves behind this 2 on top of the 2 over 12. I've taken the k out, I've taken the k plus 1 out, so I've just got the 2 k plus 1 left. The outside's done for now then, so this just stays as 1 over 12 k plus 1. But now we're going to expand and simplify the inside, so we're going to get a quadratic, but like I said, that's fine. You should never be expanding more than a quadratic. Put in the like terms. Minus 2. And you should look to see then if this resulting quadratic will factorize. And you can use calculator to help you if you need to. I think it will. So here's your final fully simplified answer. The one underneath is very similar, just involves 3 terms rather than 2. So we're going to do the same thing this time, though. This one to show that question, I thought I'd do it right one. First things first, I'm going to deal with the coefficients of these and numbers in front of me. So the first one, I've got a quarter, then I've just got 1 in the middle one, and I've got 9 over 2. So I'm going to write all of these as something of 4 for a common denominator, because that way then I can factorize out that quarter. So now that we've done that, let's factorize each of these terms. So they've all got the quarters in common, I can take that out. Each of these 3 terms has an n in common. I can take that out. They also have an n plus 1 in common, so I can take that out as well. From the first term, we've taken out the quarter, we've got an n left and an n plus 1 left. From the middle term, remember that we have 4 over 4 for that one. So we've got the 4 left from the top. We've taken out the n, we've taken out the n plus 1, but we've got 2n plus 1 left. The last one, we took out the 1 over 4, but we've got that 18 left on the top. We've taken out the n and we've taken out the n plus 1, so the 18 is all that's left behind. Now we're going to expand inside that square bracket. N squared plus n plus 8 n plus 4 minus 18. Simplifying that. Using n squared plus 9n minus 14, which is what the question asked. So in this pack, we're going to give you some standard results for sums of natural numbers. We're going to give you not just natural numbers, so we're going to give you sum of r, we're going to give you the sum of r squared and sum of r cubed. Some of these you get on the formula sheet, some of them you don't, so something you need to learn. This one is not on the formula sheet. Need to learn it. You can do this as a sum of an arithmetic series though. So this is, if we're adding the first n natural numbers, this is 1, 2, 3, 4, so on. This is an arithmetic series. The first term 1, common difference 1, and last term n, sorry. If you put this into the formula on the formula sheet, you will get n over 2, n plus 1, or half n plus 1. So you need to learn this on the formula sheet. Now these series here, you could just shove them into your calculator and evaluate them, but we're going to practice using the formula because it's an important thing to do. So this is evaluating the sum from 1 up to 9. So we're going to sub n is 9 into this one, which is going to give us 45. You can check it in the calculator. This one needs a little bit more work first, so it doesn't start at 1. So to deal with this, we're going to do the sum from 1 up to 20 of r, but then take away the first 10 terms. But now we're starting at 11. So subbing in 20, so 20 over 2, 1, and over 2. 10 plus 1 gives you 210 minus 55. 5. Again, notice in this example, it doesn't start at 1 at the bottom, it starts at 5. So the first thing to do is to split this sum up into the sum from 1 up to 2n minus 1, and then take away the first 4 terms. So 1 less than the bottom one. Using the letter k, but it's the same thing. So using the formula, we've got a half. N in this case is 2n minus 1. N plus 1 in the final bracket gives you 2n minus 1 plus 1. And then we're going to take away a half times 4 plus 1. Simplifying this, we've got a half. 2n minus 1. 2n minus 1 plus 1 goes to 2n. And that's obviously that 2 cancels with that. And here we've got a half times 4 times 5 gives you 10. Expanding this out using 2n squared minus n minus 10, which is what they asked for. N is greater than equals 3 conditional, and this is just to make the top work. If you had n is 2, for example, and then you get 3 on the top, which is lower than the 5 on the bottom, and you can't have that. You're allowed to do some sort of algebra with series functions. So if you've got a constant time fighting function, you are allowed to move that constant out to the front, just like a factorizing, but only if that is a constant. You can never move like r's or k's or whatever. And if you've got the sum of 2 functions added together, you can split that up into 2 series, which is a useful thing to do. So, for example, this first one here, I can split this sum of 3r plus 2 up into 3 times the sum of r, taking that 3 up to the front of the first bit, plus 2 times the sum of 1. The sum of 1 we haven't mentioned really, but if you think about it, so the sum from 1 up to n of just 1 is 1 plus 1 plus 1 plus 1 n times. This is just n times 1, which is just n. Okay, it's not on the formula sheet, but you do need to. So using this formula that we had before, so the sum of r is half n plus 1. Sum of 1 is just n, so we've got 2n from there. Again, I'm going to use my factorizing technique here. So I've got what I want to do is I want to write 2 as something over 2, and write it over 2. Then I can factorize out. They've got a half in common and they've got an n in common. And the first term that leaves behind the 3 and the n plus 1. From the second term that just leaves behind the 4, which will be the r and expand that out to 3n plus 3 plus 4. Gives you the 7 at best. Similarly on this one here, so we can split this up into two sums. We can split it 4 times the sum of r minus 2 times the sum of 1. Both these start at 1 and n. Put your formula in, so sum of r is half n plus 1. Sum of 1 is just n. Now in this case, I said 4 times half gives you just 2, so no need to deal with the fractions. You could factorize this, but simpler here to just expand this out and get a quadratic. So 2n squared plus 2n minus 2n, those 2n's cancel, and you just get 2n's. As you try underneath, please could you pause the video and have a go at that one, and I'll reveal the answer in a second. So for the show that one, split your sum up. Each formula, you can expand it out and then refactorize it because it's just a quadratic, or you could factorize it from the start. So take out, I'd take out n over 2, half n up to the front, and then you get your 3n plus 17 in the bracket. For this one, remember you split this up into two sums. So this is the sum from 1 up to 30 minus the sum from 1 up to 19 to 1 less than that 20 at the bottom. You should end up with 902. You can check this on your calculator, but I do want to practice doing this by